Most years, the inner solar system only greets a handful of quiet wanderers, faint comets that come and go, unnoticed by most eyes. But this year is different. From the edge of interstellar space, a stranger has crossed the cosmic threshold, moving faster, shining brighter, and stirring questions we've never dared to ask. Its name is 3I Atlas, the third interstellar object ever discovered. A traveler from beyond our sun, older than the solar system itself. For months, telescopes around the world have turned their gaze toward it, watching as it drifts closer, growing restless under the pull of the sun. Now, as it approaches perihelion, its closest point to the sun on October 30, scientists and skywatchers alike hold their breath. Maybe it's just ice and dust, torn from forgotten worlds. Or maybe it's something built to travel the stars. The story of 3I Atlas began in early July 2025, when a telescope high in the mountains of Chile picked up a faint, fast-moving light. It was spotted by ATLAS, the Asteroid Terrestrial Impact Last Alert System, a NASA-funded network designed to scan the skies for objects that could threaten Earth. But instead of danger, ATLAS had found wonder, a visitor from another star, cutting through the darkness like a message written in motion. Within days, astronomers around the world rushed to confirm the discovery. Papers began pouring in, from just 4 in July to nearly 70 by September. A global scientific rush rarely seen in modern astronomy was now unfolding in real time on star maps. Its path was traced beside two earlier interstellar travelers, Oumuamua, discovered in 2017, and Borisov in 2019. Together, they form a new kind of constellation, one made not of stars, but of stories carried across the void. From the very first measurements, scientists knew something about 3I Atlas didn't fit the rules. It was moving at a staggering 58 kilometers per second, nearly twice as fast as an ordinary comet, fast enough to escape the sun's gravity with ease, and based on its chemical signatures and trajectory, researchers estimated its age between 3 and 11 billion years older than our sun, older than every planet we know. In its wake, it left a trail of questions. How could something so ancient still be so alive, releasing gases and light as if it had just awakened from an endless sleep, older than our sun, faster than any comet we've ever seen, and growing brighter by the week? Whatever this traveler was, it wasn't following the patterns we thought we understood, and that realization sent ripples through the scientific world. On the 21st of July 2025, the Hubble Space Telescope turned its gaze toward 3I Atlas, capturing a glimpse of the interstellar visitor from 446 million kilometers away. In the photograph, the background stars appear stretched into soft streaks, a silent proof of just how fast this object is moving through the darkness. At the center, a faint teardrop of dust and gas trails behind a tiny, icy core, a nucleus estimated to be between 440 meters and 5.6 kilometers across. At first, scientists believed the brightness they saw came from the solid core itself, but Hubble's new data revealed that most of the light was reflected from the coma, the glowing cloud of gas surrounding it. The realization changed everything. What once seemed like a massive comet turned out to be smaller, sharper, and far more complex than we had imagined. Now that the dust has cleared, we see a smaller, sharper traveler than we first imagined. On the 6th of August 2025, the James Webb Space Telescope turned its near-infrared spectrograph toward 3I Atlas, Leading the study was astrochemist Dr. Martin Cordner, a scientist known for decoding the chemistry of comets and distant worlds. What Webb found was nothing short of astonishing. Instead of the usual water vapor that dominates most comets, the spectra revealed powerful emissions of carbon monoxide and carbon dioxide, while water, H2O, remained faint and quiet. The data showed violent jets bursting from the comet's surface, dust shooting not away from the sun, but toward it, carried by invisible plumes of carbon dioxide gas. As the fine grains fragmented, they caught sunlight and fled brighter, creating a shimmering glow that defied every expectation. To scientists, it was a physical process to storytellers. It looked like rebellion. Even the dust was rebelling against the sun. While Hubble and Webb were still preparing their next observations, another NASA mission had already captured something extraordinary, long before anyone realized it. Between May 7 and the 2nd of June 2025, the Transiting Exoplanet Survey Satellite, better known as TESS, recorded 3I Atlas drifting across its wide-field cameras. At that time, the comet's distance from TESS decreased by 0.9 astronomical units, close enough that its brightness should have increased by only about 1.5 times. But reality had other plans. Its light suddenly intensified, not by 1.5, but by 5 times, jumping from a magnitude of 20.5 to 19.28. Something deep inside it flared awake. The findings were later confirmed by TRAPPIST North and South observatories, proving that the surge wasn't a measurement error, it was real. When scientists tried to chart its light curve, the data came back messy and erratic. 2 faint pulses appeared, one every 29 hours, another every 16. Ground-based telescopes later confirmed the shorter rhythm 3I Atlas was spinning roughly once every 16 hours. A perfect balance between motion and mystery. Top of form. On the 27th of August 2025, the Gemini South Telescope in Chile captured the clearest image yet of 3I Atlas, a thin, luminous streak stretching nearly 1/120th of a degree across the sky, twice as long as what was seen in July. Leading the observation was astronomer Bin Yang from Diego Portales University, who detected a faint but unmistakable CN band, the chemical signature of cyanide. The process, though deadly in name, is beautifully natural as water. H2O begins to sublimate from the comet's icy surface. It releases hydrogen cyanide, HCN, which sunlight then breaks apart into its atomic pieces at a distance of about 2.5 to 3 astronomical units from the Sun. 3I Atlas had started to exhale, breathing gas and light into the vacuum of space. Each breath, faint yet measurable, told scientists that this traveler was waking up slowly, methodically, like something ancient remembering how to live again. In early September 2025, a new study revealed another layer of the comet's mystery. 3I Atlas was releasing roughly 8 times 10 to the power of 23 molecules of cyanide, CN, every second. Yet something important was missing. The data showed an unusually low presence of dicarbon, C2, giving the comet a chemical profile unlike most others ever studied. Its C2 to CN ratio measured below 0.09, placing it firmly in the rare class of carbon chain depleted comets. It's missing the carbon chains most comets are built from. That ratio, a comet's chemical fingerprint, tells astronomers where and how it was born. A value this low suggests it formed in an extremely cold region of an ancient nebula, far beyond our Sun's reach. Interestingly, the interstellar comet Borisov, shared the same trait, hinting that both travelers may have come from a similar birthplace somewhere between the stars. On the 5th of September 2025, a new paper led by astronomer Zuri Gray sent shockwaves through the scientific community using telescopes across Chile, the Canary Islands, and Bulgaria. Her team measured how light scattered off 3I Atlas and found something no one had ever seen before. Normally, light reflected from comets is positively polarized, meaning its waves vibrate perpendicular to the scattering plane, the line connecting the sun, the comet, and the observer. But 3I Atlas did the opposite. It produced a deep, narrow, negative polarization branch, with light polarized parallel to the scattering plane, a behavior no comet, asteroid, or interstellar object had ever shown. For the first time, light itself broke its own rules. To visualize it, imagine sunlight reflecting off a still lake through polarized lenses. The glare shifts and dims a reminder that even light can be bent and controlled. But 3I Atlas bent it in a way nature wasn't supposed to. To scientists, this discovery opened a new frontier in understanding how dust and gas scatter light in alien environments, where physics begins to blur into the unknown. On the nights of September 7th and 8th, while much of the world watched a lunar eclipse turn the moon a deep red, two astrophotographers in Namibia, Michael Yeager and Gerald Raymond, aimed their cameras not at the moon, but at the darkness beside it. There, gliding silently through the void, was 3I Atlas, glowing a soft, unexpected emerald green. The color came from D-carbon C2, a molecule that fluoresces around 580 nanometers when energized by sunlight. But here's the paradox. 3I Atlas is carbon depleted. By all logic, it shouldn't have enough C2 to glow green at all. A color it shouldn't have yet. It glowed. Scientists are still debating the cause. Perhaps a chemical reaction buried deep within its core has awakened, or perhaps we've just witnessed a phenomenon no one fully understands yet. As the mystery of 3I Atlas deepened, it began drawing attention beyond the world of science into the realm of speculation. One name kept appearing across headlines: Avi Loeb, a Harvard astrophysicist known for challenging conventional ideas. Loeb argued that early estimates placed the comet's diameter at around 10 kilometers, far too large. He said, to be a naturally formed interstellar object. From that, he proposed a bold possibility. What if 3I Atlas wasn't entirely natural? What if it was an artifact, an engineered traveler, sent across the stars? He even referenced the dark forest theory from the Fermi paradox, the idea that advanced civilizations may choose to remain silent, hiding from potential cosmic predators. It's an idea that excites imaginations and divides scientists, yet more recent evidence told a simpler story. On August 7, Hubble's data refined the comet's size to no more than 5.6 kilometers, disproving the giant object claim. Its orbit and acceleration fit perfectly within natural models, no hidden thrust, no engineered trajectory, no sign of artificial design. Still, Loeb's hypothesis reminded us of something deeper, that curiosity and imagination are essential, but evidence must always lead. In science, imagination opens doors, but only evidence keeps us grounded. On the 30th of October 2025, 3I Atlas will reach its perihelion, its closest point to the Sun, passing at about 1.4 astronomical units. At that time, it will slip behind the Sun, hidden from every telescope on Earth, disappearing for a few quiet weeks. But this is not the end, only an intermission. By early December, it will re-emerge from the sun's glare, beginning a new cycle of observation and discovery. The next watchers are already preparing. NASA's SOHO will track its journey past the sun. SphereX will scan its near-infrared spectrum. MAVEN will measure solar wind reactions. And from afar, Hubble, James Webb, and Gemini will continue their vigil. All eyes, from Earth and beyond, will follow this silent traveler as it vanishes and returns again. Maybe it's just dust and ice, torn from forgotten worlds. Or maybe it's a mirror reflecting how little we truly understand. The signal fades. A faint hum remains like a whisper from the void, asking us to keep watching. If you want to be here when it returns, subscribe and stay on watch. Bottom of form.